देख रहा हूँ। मैंने तो कर दिया स्टार्ट ब्रॉडकास्ट। So guys, are you able to hear my voice and see my screen? If it is so, kindly comment in the QA section so that we can start with the webinar. Anyone who is online able to see my screen and hear my voice, just give a thumb fine. Let us start with doubts one by one. वो नेट ही गया हुआ होगा अपना, कमजोर चल रहा होगा और क्या। अब देख शेयरिंग चली गई ना बीच बीच में। क्या करें फिर, ऐसे तो यार आती जाती रहेगी तो। So guys, are you able to hear me? So let me take first doubt. So first doubt is by Divya Sharma. What is the prime reason of conducting open circuit test on LV and short circuit test on HV? So the basic reason is that the open circuit test is conducted at rated voltage and the short circuit test at rated current. So if we want to apply rated voltage, it is easier to apply a lower amount of voltage than a higher voltage. That is why we will apply the rated voltage on LV side and we will open circuit the HV side. When it comes to current, we have to conduct short circuit test at rated current. Obviously, at the high voltage side, rated current will be less, and at low voltage side, rated current will be more. That is why we prefer HV side for conducting short circuit test so that the amount of current required is less and it can easily be obtained. That is the primary reason. The next is from Anirban Das Gupta. A 440 volt 50 Hz star connected alternator has rated full load current 50 ampere. RA is equal to 0. To induce rated voltage at no load, if IF required is equal to 2 ampere, when short circuited, if needed to circulate rated current, IF needed to circulate rated current is 1.5 ampere. When machine is delivering rated load at rated voltage at 30-degree lead, IF is equal to, okay, 40 volt, 50 hertz, 4 pole star connected has full load current, RA is equal to 0. To induce rated voltage at no load, required RA is equal to 2 ampere. When short circuit IF needed to circulate rated current. Okay. Tin is delivering rated load at rated voltage at 30-degree lead. IF is equal to. So it is saying at no load, so yeah, let us proceed. It is saying at no load, IF is equal to 2 ampere. Okay. So at 2 ampere, that means EF is equal to rated voltage. Rated voltage is how much? 440 volt. That is 440 by root 3, considering the start. Now, to induce rated voltage at no load, IF is 2 ampere. When short circuited, the IF needed to circulate rated current is 1.5 ampere. So, short circuit, IF is 1.5 ampere for IA rated. Now, what happens is from here we can calculate short circuit ratio. It will be 2 upon 1.5. It will be the reciprocal of excess in PU 2 upon 1.5. That means synchronous reactance in per unit is 0.75 pu. From this synchronous reactance, what I can do is now I can calculate excess in ohms. Okay. Or let us rather solve in pu only. We will later convert in ohms. So I know excess is 0.75 pu. Now it is asking the IF required when machine is delivering rated load at rated voltage at 30-degree lead. So that means terminal voltage is 1 pu, IA is also 1 pu, and phi is 30 degree. From this I can calculate EMF 1 angle 0 plus 1 angle 30 into J 0.75. So 1 plus J or 1 plus 0.75 at an angle 120. From here I will get the value of EMF. Once I get the value of EMF, I know IF is equal to 1 pu, that is equal to 2 ampere. So for that EMF between field EMF and the current, that is I'm assuming the magnetization curve is linear. That is I'm operating in this region. Okay. So just calculate the EMF and then apply unitary method in order to find the field current. So what I'll do is I'll plus one every question that I'm answering so that I keep it as a record. Next is from Alok Bhardwaj. Magnitude of fault current for a line to line fault, I think, is 8.66 pu. If pre-fault voltage at fault point is 1 pu, then value of Z1 plus Z2. Now fault current in line to line fault is root 3 upon Z1 plus Z2. It is given to me as 8.66. Okay, 8.66 means 5 root 3. Now this means Z1 plus Z2 is 1 by 5 2. So that is the value of Z1 plus Z2. The next is again from Alok Bhardwaj. If PE is equal to 1 pu, delta is 30 degree, PM2 is 0.0, what it is? 0.5 pu, I think. PM3 is 1.5 pu. Then for critical clearing angle, delta max is pi minus 30 degree or delta is sine inverse. Actually, delta max is always pi minus sine inverse Pm by Pmax 3. Okay. But when we talk about the fault in which the original network is restored after the fault clearing, in that case, actually, the power maximum before the fault and after fault clearing are equal. If such a case happens, then what happens? This formula is converted to pi minus sine inverse Pm by Pmax 1, which is actually pi minus delta naught. Okay, that is just a special case of this in which the original network is restored after the fault. Next is in Mer's price protection scheme of alternator, if I1 and I2 are CT secondary current, NR and N naught are the number of retaining and operating coil, then torque balance equation is. Then the torque balance equation is operating coil carries the current difference of the two current should be equal to NR average of the two currents. Okay. That will be the torque balance equation for the case of Mer's price differential protection scheme. Next is from Anirban. In synchronous machine regarding salient pole, should we expect only formula based question or phasor diagram? See, in salient pole machine, basically we can expect two type of questions. Or rather, let us say three types. First one is to find delta. For that, we can remember the formula of tan psi Vt sin phi plus Iaxs over Vt cos phi Ra, and then plus minus based on lagging and leading. The next one is to find power. For that, we can remember the formula for power. And the last one is to find EMF. This can easily be done using phasor diagram. So these sort of questions can be expected from a salient pole type of machine. And now, since the topic of salient pole has arisen, let me show you one method that I have learned recently. See, always remember internal power factor angle psi is equal to delta plus phi. We can derive different cases based on this. How? For the case of motor, replace delta by minus delta. For the case of leading, replace phi by minus phi. Okay. So now see, generator. For lagging power factor, psi is equal to delta plus phi. For leading power factor, psi is equal to delta minus phi. For motor, psi will also be negative. For motor lagging, what to do? Minus psi is equal to minus delta plus phi, which means delta is equal to plus phi. What about leading? Delta is equal to psi minus phi. I have just replaced here phi by minus phi. So this sort of relation you can always remember so that you do not have to remember different relation between the internal power factor angle and the power factor angle. So you just remember one relation, that is for generator and the lagging power factor, and then all the relations can be derived on that basis. Where is that question? Okay. Now let us proceed further. Finding fault current using Thevenin and using EMF method is same. If it is, how I am really confused whether should we consider the pre-fault current. See, first of all, the thing is about pre-fault current. It has only been asked in gate once. And how to do such type of question? So step 1, construct network before fault using steady state reactance. Okay. Then step 2, calculate EMF using given load. Load current would be given to you. That is, we are applying 400 megawatt, 500 megawatt load. Convert that in PU and calculate the current. Step number 3, replace reactances by subtransient values. Once you do that, determine fault current. So that method is universal. That should be always followed. No need to add pre-fault current to fault current and any of these. That is only applied in Thevenin method. But Thevenin method fails when this subtransient reactance and steady state reactance is different. Okay. Only once it has been asked before in GATE, in that we had to calculate the EMF and then the fault current and not use the Thevenin equivalent. That is why it is safe to use this method where we calculate EMF and then find the fault current. In synchronous machine question in concept booklet, it is solved using a phasor diagram. I am not able to understand the approach. I have posted the photo in the comments of the webinar post. 1 minute, let me check that out. So what is done in this problem in which it has solved using phasor diagram is it has used the MMF method in which I have taken one corresponding to the reaction and one corresponding to the rated EMF. And once we add those using phasor diagram, we get the resultant MMF required to produce the rated voltage. So that also you can do. That is a phasor approach. You can study it using the MMF method. Okay. So what it has done is resultant MMF is equal to field MMF plus armature. Because when it is saying the MMF required to current circuit, that is basically the field current or the MMF required to overcome armature reaction. Okay. So that is corresponding to FAR. Once I have field MMF and armature reaction, we can calculate resultant MMF. Next question is by Naveen Kumar. The next problem is, in Nyquist rate of xt is omega naught, then what is the Nyquist rate of signal xt minus x of t minus 1? Xt cos omega naught t. See, when we take two signals such like this, so here we have two signals, one is the original and other is a shifted version. So shifting does not impact bandwidth. So bandwidth is same. Okay. Or neither the signal is shifted in frequency domain. It is just multiplied by e raised power minus j omega because shifting is 1. So hence 1 we have xt cos omega naught t. So cos omega naught t is basically used for modulation. If this is our baseband signal, modulation, this signal spectrum will be shifted to omega naught and minus omega naught. Now you are saying Nyquist omega naught. That means it was up to omega naught by 2. That is why the Nyquist rate is twice the maximum frequency, that is omega naught. So now it will extend up to 3 omega naught by 2 from omega naught by 2. So maximum frequency is 3 omega naught by 2. Hence Nyquist rate is omega that will in this problem. Generator rate and 400 megawatt operating in parallel, droop characteristic 4% and 5%. Assuming both are operated at 50 hertz at no load. See, when you get these type of questions, droop characteristics, do one thing. Draw curve like this. Okay. We have here 50 hertz. So when the droop is 4%, that means the frequency will go up to 48 hertz. And when it is 5%, it will go up to 47.5 hertz. Then what to do is draw a line like this which has constant frequency f. Corresponding to this, we get 2 points. This one is P1, this one is P2. Now it is given that both are sharing a load of 600 megawatts. So P1 plus P2 is 600. Now how to find the equation for P1 and P2? That we will do using similar triangles. This one is P1 full load. And this drop is basically 2 hertz. So now by the concept of similar triangle, this smaller triangle and this complete triangle are similar to each other. That is P1 full load by 2 should be equal to P1 by 50 minus F, because this distance will be 50 minus F. So P1 will be P1 FL 50 minus F by 2. Similarly, P2 will be by same concept P2 FL 50 minus F, but now here it will be 2.5, because from no load to full load the difference is 2.5. So that way we have three equations and three variable, that is P1, P2 and F. All three can be calculated. A 200 volt DC shunt motor 17 kilowatt with an input of 20 kilowatt. Field winding resistance 50 ohm, armature resistance 0.04 ohm. Efficiency will be armature equal. Maximum efficiency is obtained when copper loss or variable loss is equal to constant loss. Now let us see in this problem what it is given. DC shunt motor. So total losses are given to me as input minus output 20 minus 17, that is 3 kilowatt. Now it is saying that the field resistance is 50 ohm. So how much is the field loss? 200 square V square by R, because it is a shunt machine. So it will be 800 watt. Okay. Saying armature resistance is 4 ohm, 0.04 ohm. Okay. If 800 watt is the field loss and we have total loss of, okay, input is 20 kilowatt. From here I can calculate the supply current 20,000 by 200. Field current will be 200 by 50, that is 4 ampere. So from here I know IA will be equal to 96 ampere. Calculate copper loss 96 is 0.04. I have copper loss, I have field loss, and I have total loss. So if I subtract this, or let me write 3000 minus 800 minus 96 square into 0.04, what I will get is, I will get the rotational losses. Now, the maximum efficiency will be obtained when copper losses is equal to rotational plus field loss, because this will be the constant loss. So from here, once you obtain rotational, just add the field loss in that to determine the total loss. Next question is, when we have the final capacitor voltage. See, Anirban, I just now saw your solution. Actually, your solution is correct. What I feel is, initially, VC1 is not equal to VC2. So what will happen is, current will flow. This current will dissipate some of the charge in resistor. So I cannot say that the charge is conserved. But when the current flow stops, why will it stop? When VC1 becomes equal to VC2, the net voltage becomes equal to 0. When net voltage becomes 0, current becomes 0. So charge transfer will stop. So directly we cannot say that the charge will be conserved. Initially there will be some current flow and the charge will redistribute itself, and finally when both voltages are same, the current flow will stop. So Anirban, what you do is you just try to find out the steady state value of other capacitor also, and if you see the voltages are equal in steady state, then that means the current will stop flowing. Okay. So that should be the concept as per me. So let me know in the Facebook group only what are your findings and we will discuss it further. Next is how to find out the quality factor using transfer function approach. Basically, in transfer function, what you do, uh, but I am not getting in transfer function approach. Otherwise, in transfer function, what you can do is, yeah, one thing you can do, calculate resonance frequency using transfer function and calculate bandwidth. Bandwidth, how will I calculate? Using 6 dB frequency. And the ratio of both will give me quality factor. Okay, that can be done. So that should be the case. If you have any other method that you have seen in certain book, then let me know, post it on the group. I'll see the solution and I'll explain you what they have done specifically. The next question is from Alok. In transmission line, if sending and the receiving end voltage are maintained at same magnitude, there is real power flow from sending to receiving. Where will be the reactive power flow? So do remember it as a rule of thumb that when mod Vs is equal to mod Vr, then Qs is greater than 0, Qr will be less than 0, which means the sending end delivers power into transmission line and receiving end also delivers power into line. So that means the reactive power is absorbed by the line at both the ends. Is it fine? So that is what happens. So do remember it always. Whenever you see such a case that Qs is equal to Qr, transmission line will absorb reactive power from both the ends. For probability, actually what you can do is, there is one book, Populous, that is for probability and random variable. That you can do, from there you can solve the probability problems, and there you will find the good questions on random variable also. Hey. The next is from Jitendra. A three-phase transformer rated for 33 by 6.6 kV is connected star delta, and protecting current transformer on the low voltage side have a ratio of 400:5. The ratio of CT on the high voltage side. See, I'll tell you an approach what you can follow. There is no need to memorize any problem for this kind of questions. So no need to memorize any formula. See, primary, secondary. Primary connection is star, secondary connection is delta. So how will be the CT connected? On star side it will be delta, on delta side it will be star. Okay. So here the line voltage is given to me as 33 kV on the star side and 6.6 on the delta side. So suppose I line. Here I line is suppose I. Here how much it will be? 33 into I is equal to 6.6 into I2. So I2 will be equal to 5I. Okay. So that will be the case. Now what happens is current transformer on low voltage side have a ratio of 400 by 5. So secondary current, it will be 5 by 400 into I. And here suppose the current transformer has a ratio of 1 is to or x is to 1, let us say x is to 1, so it will be 5I by x. Okay. Now what will happen to the line current of current transformer? Here current transformer is delta, so line current would be 5I root 3 by 400. Here current transformer is star, so line current will be 5I by x. Now under normal operating condition, both current transformers should have same line current. Why? So that the relay does not maloperate. So I have to equate both these. So this gets cancelled out. So x will be equal to 400 by root 3. So the other transformer should have the ratio 400 by root 3 is to 1. Is it fine? So that is how these kind of questions can be done for the differential relay. Next question is from Amik. What is the question actually? A 3-input majority gate is defined by the logic AB plus BC plus CA. Which of the following gates is represented by the function M ABC whole bar M ABC bar C? M of ABC whole bar, then M ABC bar, then C. So you can simplify it also, na? What you do is M ABC is AB plus BC plus CA. This whole bar M ABC bar AB BC bar AC bar, then C. Then apply the same logic here. Now this becomes A, this becomes B, this becomes C. So AB plus BC plus CA whole bar into AB plus BC bar plus C bar A plus C AB plus BC plus CA whole bar plus C AB plus BC bar plus AC bar. Okay. That way, once you simplify, you will get your answer. It is just nothing but Boolean algebra. So I don't think I'll solve it any further. You can just solve it from here on. Signal system question posted in webinar post. Let me see. Okay, this one. This one was asked in actually GATE 2016. So guys, you can check out the webinar comment section. There is one signal and system question that I'm explaining right now. That question is actually very good. So here if you see, x1 j omega and x2 j omega are mirror image of each other. So I can say x2 j minus j omega is x1 j omega. Secondly, what happens whenever a signal is real? Its Fourier transform magnitude spectrum is always even. That is, it is symmetric about the j omega axis or the imaginary axis. Now, if you see, both these curves are not symmetric about the imaginary axis. That means the signals are not real. That means x1t and x2t are complex. Is it fine? If they were real, their Fourier transform would have symmetry about the imaginary axis. Now, since x2j minus j omega is x1 j omega, that means x2t is conjugate of x1t. That is by Fourier transform property, which means x1t into x2t is A into A conjugate, that is mod x1 t square. Now magnitude of any quantity is real. Since it is real, that means product of x1 t and x2 t is real. That means the answer would be C. Is it fine? So you are asking, can we take all possible combination? Yes, you can take all possible combination and then verify it from the options as well. If that seems easy to you, you can go for that method. Truth table is the most basic and the most correct method for solving any type of digital question. Transmission line and power transformer have low resistance and high reactance. See, it all depends on the cross-sectional area of the winding. In transmission line and transformer, always high currents will flow. So the cross-sectional area will be kept higher. If cross-sectional area is kept higher, that means the resistance will be low. And the inductance is directly proportional to area. So inductance would be high. Is it fine? Also, you can think in a manner to minimize the losses and improve the efficiency, we have to keep the resistances low. That is why in transmission line and power transformer, low resistance and high reactance. Next question is from Soumya Ranjan Acharya. Explain about the ampere second balance of boost converter. It is clear about the inductor current, and in that clear about the inductor current whether it is taken as instantaneous or average. See, one thing, when you are applying ampere second balance, IL will be equal to IL average. Okay. And when we are applying volt second balance, at that time, V naught will be taken as constant, V naught average. That is, you cannot consider ripple in both the quantities at the same time. Either consider the ripple in the current of the capacitor or consider the ripple in the output voltage. That is why you have to assume the average current. The next is how to remember average output voltage of all rectifier. They are almost similar. Can you list them up in a shortcut method? The thing is that you can list them down for yourself and memorize the way that you feel it is comfortable. Mostly what you have to remember is single phase, full wave, controlled. That is what actually I remember during the gate time. Semi-controlled, then three phase, half wave, and again three phase full wave, controlled and semi-controlled. Okay. Otherwise, soon crash will be launched. It will list down all the formulas. From there, you can revise it again and again. That will help you using your revision. So Naveen, actually, I haven't seen question on state space analysis. What you do is you just tag me in the comments in that question. I'll reply it as soon as possible for me. Okay. I'll reply it in the Facebook group itself. This question I'm not able to understand, but what if I have instruments of high rating? I think it refers to that short circuit and the open circuit test. The thing is that we will choose the instruments based on what side we are conducting the test. It is not that I have whatever instruments I have, I will conduct the test on that basis. So the test is determined first and then the instruments are chosen, not the other way around. Full load efficiency and power factor of a 16 horsepower 440 volt three phase induction motor are 85% and 0.8 lagging respectively. The short circuit line current is 45 ampere at 220 volt. The ratio of starting to the full load current if motor is provided with a star delta starter. Starting to full load current. So the starting to full load current, if we want to find out the ratio, that actually becomes 1 by 3 times the star connection. Sorry, delta connection in star delta starter. Okay. So short circuit line current is given to me as 45 ampere at 220 volt. Okay. Full load efficiency and power factor of a. Okay. Then from here I can calculate full load current. Full load current would be how much? 16 horsepower is given to me. 16 into 746, that will be the output power, divided by 0.85. Then root 3 into 440 into zero point 0.8. That will be the full load current. Next, determine the short circuit current, but with the rated voltage. Here it is giving me 220 volt, but I need at 440 volt. As the voltage double, the current will also be double. Okay. So these are line current, short circuit current, and the full load current. So in delta connection, I can calculate ISC by IFL. But with a star connection, this value will become 1/3. So just divide it by the value 3. That is how you can calculate the ratio of starting and the full load current. So are there any other questions that are left out that I might not have answered? Okay. So that is what I had to tell you. And regarding your preparation, since this is the month of September has already started, what I would recommend all you guys is that you have to start revision along with covering the new courses. So what you do is you just go through your notes or whatever booklets that we have provided you and start solving questions from different sources which you can easily access, like test series, or even whatever difficult questions that you have faced in concept, you can solve them again in order to revise it. But do make a revision plan in parallel with the already ongoing subject. Then only you will be able to succeed in GATE examination. Okay. And soon we'll also launch the previous year book. From there also you can solve the previous year problems in order for the revision. What is the question that Divya has asked? In open circuit, short circuit question, if I have instrument that can be connected on LV side in SC test, actually you can conduct then a short circuit test on any other side also. It is not any problem for us. Okay. That is your choice because losses will remain same no matter which side you conduct the test. So heating will not be an issue. It is your choice. So that is not any problem. Okay. Network question posted in webinar. Let me see. First of all, it is not a network problem. It is an analog problem because diode is there. The switch S in the circuit has been closed for a long time. It is opened at t equal to 0. The steady state magnitude of capacitor voltage. See, this is a very simple question. Once the switch was closed for a long time, the inductor would become short circuited. In that case, IL would be 10 by 1, that is 10 ampere. So that is the steady state inductor current. Now what happens? Once the switch is opened, the circuit remains like this, in which inductor current is like this. So inductor will discharge through the capacitor. So inductor current equation would then be IL cos omega naught t, where omega naught is 1 by under root LC. How do I know this? So that initial value is IL. So that is why I have used cosine function. So after omega naught t equal to pi by 2, IL would become negative because cosine graph becomes negative after 90 degree. Once IL becomes negative, the diode will not be able to conduct current Because the diode cannot conduct current in reverse direction. What is the capacitor voltage? Capacitor voltage would be Vm sine omega naught t. What is this maximum voltage? That can easily be found. Half Li square is equal to half Cv square or Im square. So Vm will be Im under root L by C. So capacitor voltage will be this much, that is 10 under root. What is the capacitance? 10, sorry, inductance 10 to the power minus 3. Capacitance is 10 to the power minus 5. So it will come out to be 100 volt. So at 90-degree, capacitor voltage is 100 volt. After that, the diode turns off and it will remain off as it cannot conduct current in reverse direction. Okay. So its conduction will stop. I see a new question on the webinar comment section. It is GATE Electrical 2006. In the circuit shown in the figure, the current source I is equal to 1 ampere, voltage source is equal to 5 volt, R1, R2, R3 are 1 ohm, L1, L2, L3 1 Henry, C1, C2 1 farad. The current through R3 and the voltage source will be respectively. Okay. So suppose we assume steady state, then the capacitor voltage will be equal to V. Then we have a RL circuit in parallel to that. Suppose we assume capacitor open circuited and the inductor, what you do is just short circuit inductor and open circuit capacitor. What you will be left with is, I'm talking about steady state. This will be the circuit that will remain. Then this can be solved by basic network analysis directly. R1, this one is R2, this one is R3. Okay. So here R3 current can be directly calculated as voltage source is connected in parallel to this. So that way you can proceed. Is it fine? No, this resistance need not be removed. It is in parallel with voltage source. Here current can be calculated directly. Okay. Current in this resistance will be simply V by R3. Voltage source is how much? Voltage source is actually 5 volt. This resistance is 1 ohm. So this current will be 5 ampere. Next, what it has asked? And the voltage source current through the voltage source. So here it is 5 ampere. Here I source is 1 ampere. 1 ampere is current coming here. So this will supply 4 ampere. So answer will be D, that is 5 and 4. Okay. There is no technical reason except cost for this short circuit test. Actually, I have told you, now you can conduct the test on either side if you want. There is not any problem. Number of Boolean function that can be generated by n variables is equal to, for n variables, how many combinations can we have? Any of the n variables can have, like suppose 3. Okay. It can have 0, 1, 0, 1, 0, 1. So that is, we have 8 minterms. Okay. So once we have 8 minterms, we can choose 0 out of 8 minterms. We can choose 1. We can choose 2. We can choose up to 8. So that will become 1 plus 1 to the power 8. 2 to the power 8 function. So similarly, the total number of Boolean function will be 2 to the power 2 to the power n. Is it fine? That will be the number of Boolean function that can be generated using n variables. Now I don't think any question is pending. So let us conclude this webinar. And if you have any other queries, then what you can do is you can post in the Facebook group. There, me or any other topper will be answering. Thank you guys for attending this webinar. Hope you all are benefited by this. And keep in mind the point that I made about revising the course that you have already covered. And we are looking forward to seeing you doing well in the GATE examination. Do give it your best shot and let us know if you need any help from our side. So next webinar we'll be conducting in the next month, first week, that is in the October.